Today we're going to be taking a look at Bohr Rutherford diagrams, a really simple and easy way for students to understand what the inside of an atom looks like. Before we start on the diagrams, let's quickly refresh ourselves on the inside of an atom. So in an atom, we have our nucleus. Our nucleus is made up of protons and neutrons. Protons are positively charged and neutrons have no charge. The protons and the neutrons make up the mass of the atom, which is called the atomic mass. Outside of our nucleus, we can find our energy levels, also known as valence shells. Each valence shell holds a certain number of electrons. The first step is to find out the number of protons, neutrons, and electrons in the element. For example, in carbon, we can see that the atomic number, which is at the top left, is 6. This tells us that there are 6 protons and 6 electrons. Now, if we look at the top right, we can see that the atomic mass is 12. So this means that the number of protons and neutrons added together is 12. So since we know that the total mass is 12 and there's 6 protons, we can do 12 minus 6 and figure out that the number of neutrons is also 6. The next step is to write the number of protons and neutrons in the nucleus of the diagram. And lastly, we add the electrons to each valence shell. So, for example, if we were to take potassium, we know that the atomic number is 19. This means that there is 19 protons and 19 electrons. Now we take the atomic mass and we can use it to figure out the number of neutrons. Since the atomic mass is 39 and we know that the number of protons is 19, the total number of neutrons is 20. The second step is to now add our protons and neutrons to the nucleus. So as you can see here, we have 19 protons in the nucleus and 20 neutrons. Lastly, we have to add our electrons. So, for each electron shell, or each valence shell, we can only have a specific number of electrons that it can hold. So for the first shell, which is closest to the nucleus, we can only hold 2 electrons. The next shell, or the second shell, can hold 8 electrons. The third shell can hold 8 as well, and the fourth shell can hold 18. Now we have to add our electrons. Electrons are always added in pairs, and they are added in a clockwise direction. So first we add them at the top, then the right, then the bottom, then the left. So in this diagram, we've added 2 electrons, since that's the maximum capacity of the first valence shell. And now we have to add 17 more electrons. The second valence shell can hold up to 8 electrons, which have been added. This leaves us with 9 more electrons to add. The third shell can hold 8 electrons as well, which have been added to the diagram, and now we only have 1 electron left to add. After adding this last electron, we now have our complete Bohr Rutherford diagram for the element of potassium. To recap, first you have to find the proton, neutron, and electron number, and then you put the proton-neutron number in the nucleus. After this, you add the electrons to each valence shell in pairs going in a clockwise direction. The first valence shell can hold 2 electrons, the second one can hold 8, the third one can hold 8, and the fourth one can hold up to 18 electrons.